Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson, and Fred was telling me what he thinks a reliability engineer should do.
Well, I hadn't started yet. I said, let's hit record. So the first thing you do is if you're doing a podcast about reliability is hit record, because we probably could have talked about it for 20 minutes and then say, oh, we should have recorded that. So maybe that's the number one thing a reliability engineer should do is learn from their mistakes. But this was a question I got a couple days ago, and it was, I'm just starting in a career in reliability engineering, and I kind of excited about it, but what is it we're supposed to do, or what is it that we do? What does a reliability engineer do? And their experience was as an intern at some company that was basically, here, you go to the lab and you take these samples, you put them in this chamber, and you make these measurements, and you write them down, and then do it again and again and again. They were just, not much better, not, just a lab rat or just running experiments and not really knowing what they were doing or why they were doing or what they were measuring. It might have been just a really poor intern program. But he said, is that what reliability engineers do? And no, not really.
Yeah, it's, I mean, a lot of the times people will confuse reliability engineering with people who measure reliability as opposed to people who engineer reliability into things.
Yep.
So that's one of the first issues we see with a lot of, let's just say, initiatives to try and create a reliability engineering set of skills. That'd be the first one, I suppose, that we need to be wary of. Sometimes it's important to measure reliability, of course, but if the only thing you are doing is measuring, then you're not improving. The way I look at that is, imagine a coach of, let's just say, Usain Bolt. Of course, some of what that coach needs to do is time during practices and training sessions, how fast Usain is over whatever distance they're looking at that particular day. But that coach doesn't simply say, all right, the time was this, it's not good enough, try again. That's not coaching. Mm-hmm. That's just measuring. That's what a timekeeper does. And so a coach is a whole lot more than that, where measuring performance is obviously very important, but it's actually a very tiny part of the overall effort. So a reliability engineer isn't simply a timekeeper that measures reliability.
Well, it's a good analogy, because a good coach will say, all right, work on this or focus on this, or here's a technique, or here's the thing I noticed, let's try changing that. And it's kind of the guidance of, well, how to get better. The measurement is a tool to look for where the improvements are. There's that piece of it, but I think more importantly is that the analogy of the reliability engineer is more of the coach or guide or an engineer first, that happens to be, skilled with not only measuring reliability, but also doing a lot of other things. And I think facilitation is a huge part of what we do. I'm just, somebody was saying, well, I never run into people that the only thing they did was parts count predictions. And every time there was one to get done, they would send it to George, and George would crank this out and put it in a nice report and send it back. And if I asked him, what does a reliability engineer do? He says, well, this is what I do, and I'm a reliability engineer. And I'm like, well, I don't think so. The report didn't come with any guidance or information about what to do better or different, or it just said, all right, you gave me a list of 100 components, and if you assemble all of those failure rates together, you get this number. There you go. Have a good day. Yeah,
I mean, the reality is that you can, my son plays baseball right now, and there's obviously baseball's a game, or there's lots of sports that you can do. I mean, look at football or soccer. You can have 4 players, meet in the park and just kick the ball around and use shoes to mark goals.
Mm-hmm.
In that moment, they are soccer players or football players, but they are not Lionel Messi, or they're not there's soccer players and there's soccer players. It's the same way as I think the same analogy applies to reliability engineers. You can put reliability engineer in your signature block on an email, but just because you put it there doesn't automatically mean that you are out there doing reliability engineering. I think that maybe we could spend this whole podcast talking about what reliability engineering is not, but I think the most important thing is that reliability engineer is one who is implementing the reliability strategy or philosophy of your organization, implementing, supporting, promoting, whatever term you want to use.
Mm-hmm.
Of course, the very first part of that is coming up with a reliability philosophy or strategy that your reliability engineers that can then go and help implement. So we know certain organizations, their philosophy revolves around doing FMEAs really, really robustly and really, 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 really well. So the reliability engineers in that organization would be very savvy at perhaps training or facilitating those sorts of things. Other organizations which are just as reliable, so to speak, a lot of their philosophies revolve around HALT because they have a different sort of product line. And so the reliability engineers there would be making sure HALT is embedded in the development process, funding for it, right technicians, is there an on-site lab, et cetera, et cetera, et cetera. So before you can work out if you're doing reliability engineering stuff, you need to be able to articulately say how you're making reliability happen. And reliability doesn't happen when it complies with contractual clauses or standards, or you go through testing, you follow the US Department of Defense acquisition flowchart, which is it's so ornate and intricate. It looks like a tapestry when you take three steps back.
Mm-hmm.
So if you're a reliability engineer, if you're implementing the philosophy or strategy of your organization, if there is none, unfortunately, you're going to spend your entire career doing parts count prediction, which is not reliability engineering, unfortunately.
It's not, I don't like the word implement because it implies that the reliability occurs because that person is there and they're doing it, and they're not. And I know I've used this story plenty of times. There's one organization, their reliability engineer did all the analysis, did all of the root cause analysis, did all the reporting, did all the measurement, did the FMEA themselves. The electrical engineers would say, how do I derate this component? Because he would do it for him. He'd look, give him details to which component to pick. I mean, the guy was just spending way too much time doing stuff. And when he left, the entire program left. And so when I'm talking to the team, this electrical engineer goes, yeah, he never told me how to do this. I just would send him the bill of materials, and he'd set, this in the design, and he would send me back, how to derate it, what values to use. I had no idea how I did it. Whereas this other team, very similar product, the reliability engineer was very much more the coach. And so that they could go play soccer and get and improve themselves. They learned how to do derating. They learned how to set up a test. They learned how to do data analysis, and it became embedded within the organization. And so she finally left because she wanted to go take on another challenge and help another team get it. And so for me, it's not that I just took this great set of courses and I can do wizard stuff with data analysis. If that's not needed or called for or part of the strategy of that organization, it's kind of a wasted skill. I think the skill of a good reliability engineer is identifying, aligned with that strategy or vision of the organization, or helping to create that strategy or vision, is what's going to add the most value. What should I do to enable this team to move forward, to mature in their approach to making decisions related to reliability? And it's working on what has value. If you've heard me rail on this so many times, is somebody's running a test and nobody needs it or wants it or does anything with it, well, stop running that test. What a waste of time.
Well, I'm going to push back on your pushback of the word implement, because at least in the context I was using it, I do believe the reliability engineer is there to implement the philosophy or the strategy. That first example you had, where you had that single person who just does everything, I would argue that that's not a philosophy or a strategy. So even though that reliability engineer was doing stuff, there was no implementing of an organization-wide strategy. So,
well, the strategy was have Phil do it, just hand it off to him.
But when you say you have Phil do it, I mean, if you're not baking reliability into the design of whatever it is you're doing, and Phil can't do that because he's a reliability engineer who sits over in that office and just answers the emails and does a derating, then there is no philosophy, so to speak. And what you were talking about in the better, more advanced examples, where you had someone who is invested in creating that philosophy or strategy and implementing that across the organization.
Yep.
And that means that the individuals in that organization understand their role. They understand why it's important. They believe that their efforts are going to actually have meaningful results that can be directly attributable to them, et cetera, et cetera, et cetera.
Yep. Well, it comes down to semantics. I think you're using, and I agree with you. The way you describe it, it makes sense. It's the danger is that we formally learn all these tools, and you open up a book on reliability engineering, and it says, well, here's the 8 steps to set this up, and here's the 4 steps to do this part, and here's how you interpret this data analysis, and here's what you do in a repairable system, and blah, blah, blah. And you get all these analytical tools or procedures or techniques and sample size calculations and all that other good stuff. But that's our toolbox. It's like having a soccer ball. All right, great. Now let's go do something with it. Which one do you use and why? That's the engineering part. And that's true of any engineering discipline. They got a set of tools, but it's when and why you use particular tools.
Right.
And I think that's the engineering part. And then the reliability engineering is, we're not the electrical engineer. So a big part of what I think our role is, and I think we agree on this, is to enable that electrical engineer to design in the reliability as they're designing it. And that doesn't mean sitting over their shoulder or waiting for them to ask a question. It's guidelines and discussions and reviews and questions and encouragement and rewarding ones that are, getting it right and making great products, and highlighting areas that need improvement in the system, whether it's the life cycle document or the program manager's way they push certain priorities or whatever. It's how do we balance achieving those reliability goals and making them real, which might include measuring it, but also how do you design it in and move it up? But that's just one aspect. It might be talking to finance teams and making sure they understand how to estimate future warranty accruals, because that, in some cases, is a lot of money. And if you get it wrong, it's a lot of money going the wrong way, kind of thing.
Right. And I think you're touching on a wide range of activities, which is fair and important. I would say that that's one of the many problems that when people ask us, well, what does a reliability engineer need to do? We when we answer that question, we might use words and describe scenarios, but too often it sounds to them when we answer the question by saying, well, you tell me, what do you think you need to do? Which is a cop-out in many scenarios, in many contexts. But I think that's the skill of the reliability engineer, I should say, or the group of people responsible for it, is working out what needs to happen and being able to have the critical thinking skills to say, we really shouldn't be doing HALT here. We need to instead do this, or we should be doing more of HALT, or hang on, none of this is going to work if that accounting team or finance team you talked about is underestimating failure rates or failure probability by factor of 10. There is no checklist for the paying constant attention to your organization on its path to meeting its goals.
Yep. Well, I mean, it really came home to me of the broad scope of what we can do. When I was working with a project team as a newly hired engineer into HB, and everybody else at the table was a manager and had, 10 to some had 30, 40 people working for him. And then the program manager was basically his staff and me. And I'm like, at one point I, asked him, why am I here? And he says, you're the only person other than myself that has a role that has a scope that touches everybody here. So you're not controlling the budget for the overall team and doing all that hired and fired and all the other stuff and setting the schedule and all the stuff that I'm doing. But you need to work with all of these people, and all of those people need what you bring to the table and how you coordinate it. And it was one of those things that at that point, then it was like, oh, okay, well, here's a problem. It was a detailed problem on a particular circuit board, but the electrical engineers and the software engineers and the hardware engineers sat in different buildings, basically different rooms. It was a huge building. They weren't even close to each other. Their managers got together every now and then. And this was a problem that I realized that, if we get these three people in the room for 5 minutes, we could, come up with a solution that will work for all three teams, and they quit finger pointing. Nobody needs to know. Let's just get it done. And fortunate for me, the program manager walked in on it and go, oh, you're doing what you're supposed to do. Solving problems before they're problems. And I didn't have the electrical or mechanical or software engineering skills to do it myself, but it was seen a facilitation role to say, all right, let's, just meet me in this room and we're going to solve this problem and stop finger pointing. And it was 10, 15 minutes later, they walked out with smiles and a handshake and saying, yep, that's what path we're going to use to do that. And then I was, helping them sort out, does it really work? And with some testing that we could run, but it was oftentimes the arguments for making improvements to reliability, and because of the warranty expenses, was so easy to relate to failure rates. It trumped any other arguments. Oh, well, I can get this part for a nickel less, or I can, improve the yield on our, from 94% to 95%. All right, big deal. That's, a couple $100,000. If you take that same percentage on improvement in reliability, we save $10 million, right?
Right.
Which one do you want to work on?
Yeah, in some organizations, the answer is still, I want to work on the smaller saving, because that happens now, gets attributed to me before I move on to my next appointment, before that $10 million saving is realized later on. So, but yeah, that's a whole different podcast.
Well, yeah, but it's one of those things I think one of the roles we have is to encouraging or developing or implementing the strategy and improving the culture of the organization around reliability is not being afraid to say, do you want to tell your boss that you're not going to save $10 million so you could save 100,000 this, on this, or should I tell your boss? Mm-hmm. And it was, but it's part of, back to what you originally said, is that those kinds of discussions and trade-offs and nudging and influence and hitting, smacking some people with a mackerel kind of thing.
Yeah.
It's part of that role of improving the culture.
Yeah, and I think we both talked about essentially how the reliability engineer has to implement the strategy or the philosophy. And
well, it's better when you got a whole crowd of like-minded folks, right, not just reliability on their table, on their card or signature, doing it, but it's got to start somewhere.
Well, Yeah. Well, I think implementing is also giving this, at least the way I'm using it, using that term. We have talked about the problems of semantics of this conversation, but yeah, I think the reliability engineer needs to empower those people to do reliability stuff, not do the thinking for them, but say, hey, all you need to do to make this work for this particular bit of technology you're responsible for this part of this phase of the program, these are the things you need to focus on. Here's a training I'll give you to help you get there, and this is why it's going to work, and blah, blah. That's not doing it for them, but that is doing a lot of the, I suppose, reliability-specific critical thinking for them. And a lot of times people just need that because they've spent their entire careers being hydraulic engineers or something similar. Mm-hmm. And so one of the first inclinations people get when they're told, oh, make it reliable, is just go, well, I don't know, so let's Google everything and do all that. So it's all about implementing or the philosophy or the strategy, which means empowering people to make reliability happen. But I think what you're talking about is actually one step before that, where you, in scenarios where the philosophy doesn't exist, or is at the very least not where it should be, it's not ideal, you need to have the courage as a reliability engineer to walk into whichever boss we're talking about and saying, hey, what you said, do you want to risk not saving $10 million by saving $100,000 now? Is that what you want? Being able to have those conversations with said decision maker. Now, a lot of people can have those conversations. There's a lot fewer of us who are able to walk in and have, let's call it, constructive conversations. I've seen plenty of reliability engineers who don't have the people skills to be able to walk in that boss's office and not come across as condescending or, just listen to me because I'm the reliability guide, even though the message is inherently correct. It's the way they say it.
Yeah. The ability and the, building the trust and having the courage and doing your homework and communication skills, that's a subject for another whole podcast series of art. But yeah, you're exactly right. It's part of what we do is dealing with other people. And yeah, you got to be good at it at all levels, at all discussions. And I worked for one person that she said, she basically encourages that with every interaction, every phone call, every email, every time when I was working at HB, we were working with these different divisions, is anytime you interact with them, you have to leave them in a better state. They have to have gotten value out of that interaction. Going in and saying, I told you so, you guys screwed up, is really not all that terribly helpful. No. It doesn't put them in a better place.
But never let an atrocity go to waste. So,
no. Good disaster is always worth jumping on.
Right. So you say, look, all right, team, see how we just lost $10 million from doing that boneheaded thing? This is what I'm proposing to try and make sure that never happens again. Are we cool? Yeah, I mean, summarizing a more tactful conversation, but that's better than saying, well, you know how I told you if you did that, you'd lose $10 million. There we go.
So. Yeah, that never works. That never works. It's fun to think it, but it's like, you got to figure out a better way to get at it. That might be a subject for a whole another discussion. But
it's actually very natural because a lot of reliability engineers feel like they're butting their head against the wall. And after 9 months of doing that, when the actual thing you predicted would happen happens, there's so much anger and frustration builds up. It's very human to go, see that thing, see that burning wreck over there, see that. Do you hear me now? I mean,
here's the report from 9 months ago that predicted it, and says, here's the evidence. And you guys all waved it off as, but anyway, part of the role is, doing I like the term enables your team to build reliable products, to design and build them, and implementing the strategy. That's all a big piece of it, but it really rests on that the organization, trusts you. You have credibility, that you do your homework. You do the engineering part well, and you do the root cause analysis. You do the cost benefit analysis. You ask good questions that help people see problems in a new way. Things like that. That's not to be overlooked. It's great to run down to the lab and set up a cool measurement system or a robot that pushes buttons. That, that's fun. And I love doing that kind of stuff, but it's may not be what's the most useful activity for your time and energy.
And I use the term reliability practitioner to differentiate it from reliability engineer. A practitioner is someone who's often tasked with or happens to be particularly good at one task. So that could, let's just say someone's pretty familiar with HALT, sort of ragging on HALT. HALT's a fantastic activity, by the way. It's
fun because you really get to break
right,
stuff.
and when done well, it virtually always yields substantial improvements in reliability very quickly when it's used in the right time or in the right time of the program for the right products. But what you don't want is don't want to have a guy whose one and only skill set is doing HALT stuff and say, well, that's a reliability engineer, when you know that the only thing that guy will ever do is HALT, regardless of the context, regardless of the strategy, regardless of the philosophy. As they say, if the only tool you have is a hammer, then everything looks like a nail. That's not reliability engineering. That dude is a practitioner. Now, if that dude is a good HALT technician, but is able to, for example, say, hey, this is not going to be, HALT's not going to help this because here's why. We need to do something different. Then that dude is a reliability engineer because he's all about making sure reliability gets baked into the system or whatever it is you're making. But a HALT practitioner is the term I use to characterize someone who the only thing they're ever going to do is that activity. And often the justification is, well, we did this 5 years ago and it was awesome. You go, okay, cool. So you've solved all those problems that you had 5 years ago. It was awesome. And now all you're doing is trying to solve exactly the same problems, which apparently you've told me have been fixed because it was awesome. That's not reliability engineering.
No. And that, you see that all too often. Yeah. It's like, well, we had a great launch of this program and it did really well, so we're just going to do that again.
Yep.
No, you're kind of missing the point here, guys. It's like, no, that's not going to happen.
No.
Well, anyway, that was I thought, an interesting question as somebody's looking at, ahead to a career or an advice. And I'm like, well, you need to think a little broader than just doing a data analysis for the rest of your life. You can get a start there. You can certainly build from there, but be aware that we have such a broad scope if you choose to take it, right? And you can do what they tell you to do, and you're just a practitioner is probably the right word for it. But you also, as a reliability engineer, can be a leader and make a substantial difference in the organization. But you have to want to do it. You have to be aware that you can do it. Mm-hmm. But anyway, I gave a similar answer, and I probably am going to send them a link to when this podcast comes out so they get a little bit of a different perspective and some semantics discussion and all the other good stuff. So we'll see how it goes. But if you're listening to this and you have a different definition of what a reliability engineer should do or does, let us know. We're always open for ideas and suggestions and improvements and all that other good stuff. Plus, we'll probably make it into a future podcast and look at it from yet another angle and with some of your input. And you can do that over at accendoreliability.com/go/SOR. And that's a couple of ways to get in touch with us there. Chris and I and the other hosts are available through LinkedIn and our About pages. I think this question came with a direct email. So always welcome to hear from you and encourage you to get in touch with your ideas, comments, suggestions, and all that good stuff, because we certainly do enjoy including you in the program. So with that, Chris, I think I'm going to go, break something. You talked about HALT too much. I want to go do something.
Fair enough. Always a pleasure, Fred.
All right. Talk to you later, Chris. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.